Imagine looking up at the sky. What do you see? Clouds, maybe a plane, the vast blue expanse. But what if I told you there's a powerful, untapped resource hiding up there? Not sunlight, wind, strong, steady winds high above, beyond traditional turbines. A hidden treasure of clean energy waiting to be unlocked. We might be on the verge of a new era. The key, a kite. This isn't fantasy, it's happening now. Why the sudden interest? Urgency, innovation. Our world needs clean energy, and it needs it fast. Ground turbines and solar are great, but they have limits. They need a lot of land. They depend on unpredictable weather. High altitude kites sidestep many of these issues. They tap a more consistent, powerful wind with a much smaller footprint. This could be a game changer. How can a kite power a city? Like flying a kite on a very windy day, but massive. A large kite flies several hundred meters where winds are stronger. It's attached to a strong tether to a ground generator. Flying in a controlled figure eight, it pulls with immense force. That pull turns the generator, making electricity. Once tether is fully out, the kite changes angle to reduce drag, then is reeled back in using little energy, and the cycle repeats. We'll break down how these systems work, from the kites themselves to the ground stations that convert pull into power. We'll look at designs tested around the world, benefits like providing power to remote communities and complementing existing energy grids. We'll also cover challenges, airspace regulations, and ensuring wildlife safety. Get ready to discover the power hiding in plain sight high above our heads. To understand how these sky-high power plants work, we need to meet the three key players: the kite, the tether, and the ground station. First is the kite, not a toy, but a highly engineered airfoil built from strong, lightweight materials. Its job is to catch powerful winds and create immense tension. Next, the tether. This lifeline connects the kite to the ground. It's a technological marvel, exceptionally strong to withstand tons of force, yet thin and lightweight to reduce drag. It often contains conductive wires to transmit data and power. Finally, the ground station is the heart of the operation. Its main feature is a large winch connected to a generator. As the kite pulls the tether, the winch spins, turning the generator and producing electricity. It also houses the control systems that manage the entire process. Together, these three components work in harmony. The kite captures the wind's raw power, the tether transfers it to the ground, and the ground station converts that force into clean, usable electricity. So, how does the kite generate so much power? It's not just by floating there like a balloon. The secret lies in two key aerodynamic principles: lift and crosswind motion. First, let's talk about lift. Just like an airplane wing, the kite is shaped to create a pressure difference as wind flows over and under it. The air moving over the top surface travels faster than the air moving underneath. Faster moving air has lower pressure. That pressure difference creates an upward force called lift, which pushes the kite skyward, keeping it from falling. It fights gravity and the downward pull of the tether, but lift alone doesn't generate the massive force needed for electricity. The real genius is in how the kite moves. Rather than hover, the kite is steered by its onboard control system to fly specific patterns, a wide figure eight or a large circle. This is called crosswind motion. Think of sailing. A sailboat can travel much faster than the wind by cutting across the wind's path. The kite does the same in the air. Flying rapidly across the wind creates a powerful apparent wind much stronger than the true wind. That apparent wind multiplies the force dramatically. CROSSWIND flight is the engine of the system. As the kite swoops and turns through its programmed dance, it moves many times faster than the ambient wind. That speed creates enormous aerodynamic pull on the tether. Far more than hovering, it's like cracking a whip. The tip moves far faster than your hand because energy travels along its length. Likewise, the kite's speed and tension are amplified by its controlled sweep high above the earth. This continuous powerful pull is what the system harvests. The figure 8 is optimized to hold high tension for the longest time, maximizing energy generation. It's an elegant dance between kite and wind, choreographed by sophisticated software to create the immense, steady pull that will soon be turned into clean, renewable electricity back on the ground. Now that we have this incredible pulling force on the tether, how do we convert it into electricity we can actually use? The most common method is what's known as the yo-yo or pumping cycle. This process is divided into two distinct phases, the power generation phase and the retraction phase. During the power generation phase, the kite flies a crosswind figure 8 at high altitude. That generates the maximum constant pull. The tension unwinds tether from the ground drum, forcing it to rotate. This rotation is the key. The drum is linked to an electric generator. Same basic idea as a wind turbine. Wind turns the blades, blades turn a generator. Here, the kite's pull turns the drum, which turns the generator. As the tether reels out hundreds of meters, the generator spins and produces a steady stream of electricity. This phase can last a minute or more depending on design and wind. It's the productive part. Kinetic energy is converted to electricity and fed to the grid. Once the tether is at max length, the retraction phase begins. To reel the kite back in, the system uses a small amount of energy. If you try to pull it back while it still made maximum lift and drag, you'd waste almost everything. So the kite's control system changes its angle of attack. It flattens out like a weather vane to minimize lift and drag. In that low drag state, the ground motor reels it in quickly and efficiently. The retraction uses only about 5 to 10% of the energy produced. It's like a fisherman reeling in his line after a long run. Once back at starting altitude, the kite's orientation is reset. It re-engages the wind and power generation starts again. This yo-yo pumping motion repeats continuously day and night, generating net positive clean energy each cycle. Section 4. The unseen pilot. So, who is flying this giant kite? There's no pilot inside. The flight is managed by a sophisticated autonomous control system, an unseen pilot made of sensors and software. This autopilot is the brains of the operation. Using a suite of sensors, it steers the kite along its optimized figure 8 path, making constant adjustments to maximize tether tension. While human operators supervise, the machine handles all the second-to-second flying. Safety is the top priority with multiple layers of redundancy. If conditions become hazardous, the system automatically puts the kite into a safe mode, either landing it or depowering it to spill wind. In the event of a catastrophic failure, like a tether break, an emergency parachute deploys for a controlled landing. The entire system is designed to fail in a predictable and safe manner. Section 1. Ground gen versus onboard gen, the two main families. When we dive into the world of high altitude wind energy, we quickly see that not all kite systems are created equal. While they all share the same goal of harvesting powerful winds, engineers have developed several different approaches to get the job done. These designs can be broadly grouped into two main families, distinguished by a simple question: where is the electricity actually generated. The first family is known as ground gen, short for ground-based generation. In these systems, all the heavy generating equipment remains firmly on the ground: the winches, motors, and generators. The Kite's only job is to fly high and pull on a tether, with the power being produced right at the ground station. The second major family is called onboard gen, or onboard generation. This approach takes a cue from conventional wind turbines but lifts them into the sky. In these designs, the kites themselves carry small, lightweight turbines. As the kite flies, wind rushes through these onboard turbines, causing them to spin and generate electricity directly in the air. This electricity is then sent down to the ground through a specially designed conductive tether. Instead of using the pulling force to turn a generator on the ground, these systems use the kite as a flying platform to hold turbines in the optimal wind stream, thousands of feet up. Each of these two fundamental approaches has its own unique set of advantages and disadvantages. Ground gen systems have the benefit of keeping all the complex and heavy electrical machinery on the ground. This makes maintenance much easier and means the kite itself can be simpler, lighter, and potentially more robust. However, it requires the kite to perform that cyclical yo-yo motion of reeling out and reeling in, which means power generation is intermittent even if the cycles are very fast. It's a powerful but pulsed approach to making energy. On the other hand, onboard gen systems are designed to generate power continuously. Once the kite is at its operational altitude, it can often stay there, flying in a stable pattern while its turbines spin constantly. This promises a smoother, more consistent power output. The major challenge for this family of designs is the weight. Mounting turbines and generators onto the kite itself adds significant mass and complexity, which can affect the kite's aerodynamics and stability. Furthermore, sending high voltage electricity down a long, moving tether presents its own set of significant engineering hurdles that must be overcome safely and reliably. We've journeyed high into the atmosphere to explore a revolutionary idea, using kites to reach powerful, consistent winds that traditional turbines can never touch. Using clever aerodynamics, these systems convert immense wind power into clean electricity for our world. The benefits are compelling: more reliable power with a smaller environmental footprint and the potential to bring energy to remote places or disaster zones. But the road ahead is real. This technology is young, with significant hurdles to overcome in engineering, airspace safety, and environmental protection. The journey from prototype to global solution is long but worth taking. Pilot projects are already providing invaluable lessons, turning theory into practice. Harnessing high-altitude wind calls for collective ambition. It asks us to lift our gaze and imagine a new dimension of renewable energy. The power is there, flowing silently above us. We just need the vision and the will to reach up and bring it down to earth, securing a cleaner energy future for generations to come.